So you all know that there's an open race to artificial general intelligence, an AI model that can basically do all the tasks a human being can. And when you think of companies that are in this race, you think of OpenAI, of Anthropic, of Meta, and then of course, Google. Do you know what? There's a specific point here that you're missing. Google is a commercial entity that does everything from search to email. It's in the race to deliver those powerful AI models to you. But the question is, if Google is so busy doing all this other stuff, who's making the models? Who's doing the research? Well, that's where the plot gets interesting. Google made an acquisition in 2014 of a company called DeepMind, founded by Demis Hassabis, Shane Legg, and Mustafa Suleyman. Yes, the same Mustafa Suleyman who is now the CEO of Microsoft AI. DeepMind is Google's AI arm. But here's the thing, most people don't know much about Google DeepMind. It's a mystery. How it works, what the office looks like, what they're actually working on, what the leadership is like. It's a secretive company. But I got access. In fact, Google DeepMind, along with the Royal Society, hosted an AI for Science forum. And this was a science forum that was polymathic in nature. You need to have a bit of understanding about AI, a little bit about medicine, a little bit about mathematics, software in general, people, and even game development. So there were 4 Nobel laureates and a bunch of really smart people there. However, there were only 2 creators there, me and Veritasium. So not only did I happen to see everything that happened in the AI for Science forum, constantly trying to keep up with the conversation, but we also got to see the insides of DeepMind. Not just that, I ended my London trip with a podcast with Pushmeet Kohli, who is the Vice President of Research, to unravel the mystery of DeepMind. So I'm here to show you the insider view of the company. See, as somebody who doesn't make the models but fine-tunes them and then uses them to make useful things that users can use or view or play, being able to get this access, for me, selfishly, means I can know what's coming from years away. Of course, when I say some of these things, a lot of people in the comments are going to shout at me, like when I said AI would help solve design, when I got preview access to DALL-E a couple of years ago. But I think for those that are curious and want to build on top of these models, who want to work in applied AI, this video will be very useful. Plus, to see how the smartest people in the world think, how they work, what their ambitions are, what they read, all of it is very useful. They don't think about the world like normal people. Okay, so let's start with the AI for Science forum. The night before was a welcome dinner. Unfortunately, photography was banned, so there's a bunch of deans of colleges, researchers, and also the media. There were reporters from The Guardian, The Sun, and a bunch of prestigious publications. Like I said, there were only 2 creators, Dr. Derek, Veritasium, and me. Now, you might ask, what are creators in the media doing there? It's a science forum. The answer is very simple. Research and progress stays in very small rooms unless these researchers and media coordinate to get the word out there. It turns out that even though awesome research is happening, the world probably doesn't know about it. For example, did you know that AlphaFold 3 is now open source? Well, now you know. And that is the value of having the media and the creators there. We can help this new technology and developments in science reach more people. My audience is now 40% global and reaches 100 million views across platforms on short-form content. And companies like Google and Meta have me there because it's a very specific type of smart audience that we put together here, the early adopters. That's right, large companies think you, the viewer, are smart if you're watching this kind of content. So if you're not already subscribed, you should hit the subscribe button. Anyway, it was a great dinner and I learned some of the secrets of the Royal Society. See, the Royal Society is a society of distinguished scientists. There are a bunch of stuff like treasures and weird locks and a lot of paintings. Someone showed me a painting and said that's an actual painting of Isaac Newton there. Now, I wasn't able to verify this, but it seems like it's true. The next day, the forum started and I got to hear all the panels. So there was a lot of talk about AI and there was also a lot of talk about stuff I didn't really understand, like material sciences. I also learned that they're making a new type of gene-edited cow where the microbiome genes are edited. By targeting specific microbes responsible for methane production, these scientists are aiming to create cattle that emit significantly less methane. So they're actually addressing a major source of greenhouse gases in agriculture. And that leads me to an interesting point. One observation I made here, how none of these people are stuck to one specific domain. This problem statement of the cows is at the intersection of genetics, microbiology, and environmental science. Like, my one big learning from this entire London trip and meeting all these awesome people is that most of this outlier, extreme success comes from being a polymath. A polymath is somebody who has a wide range of knowledge across many different subjects. In fact, it turns out if you're really good at one thing, you learn the skill necessary to learn things. So if you get very, very good at something, let's say you get very, very good at software engineering, you have not only learned software engineering, you've also learned the skill on how to learn something. And then you can apply that learning skill to other domains. Take me, for example. I think I can do content. I've done software for more than a decade. I can do applied AI, and we built a lot of things in applied AI. And we can develop games as well. We've made a bunch of demos in the past, both 3D and 2D. Actually, in my personal opinion, I think I can pick up anything in software in general. But most people in the world tell me, you can't do all of these things. You have to do just one thing. And I tend to struggle with this line of thinking. Because the thing is, I enjoy whatever problem statement I'm working on. And if you follow me on Twitter, you'll see that I spend months trying various things in that domain to understand it and get better at it. These people at the event were so inspirational to me because they are like that, but on steroids. They're all in their 40s and 50s, but there's a multi-dimensional universe in their brains. I never once heard someone say, oh, that's not my domain, I don't want to understand it. Instead, they would ask questions. Well, what does that mean? Is it similar to this? This is how I think it works. Am I correct? Can you give me feedback on where I went wrong? And most of these people have figured out that across domains, there are a ton of repetitive patterns, especially when it comes to working with people or computers. Whether you're building a building or whether you're doing research, ultimately you are also working with people across both. So a lot of repetitive patterns are there, and most of these people today across all these domains are of course using computers. Like the geneticists are doing an insane amount of work on a computer. So the better you are at adapting to and using new technology or software, the better the geneticist you become. Like the only reason I know anything about genetics, apart from what I studied in college, is because of curiosity. I don't know if you know this, but I mapped my whole genome in 2017. And then I used this online tool called Prometheus to give me more information on my genome. Like I had no agenda. I'm not trying to do this to pass some test. I was just really curious about my own genome. And the one thing about these people, all these people there, is that they're all very curious about life, about the world, about other industries and domains. I'm actually starting to lose faith in the idea of a person who's just very, very good at one thing and not curious about anything else. You know, all our lives we hear about the expert, the person who's very, very good at one specific thing and knows nothing else about anything else or doesn't have any relevant information about anything else. I think that is a TV level understanding of people. Like on TV, we have experts. We have astrophysics experts who come and talk about space and science, or the economics expert who comes on TV and speaks about economics. When I was young, I thought that was the peak of success. But now that I'm older, and I get to hang out with people who are very, very successful, not just 50 lakhs an annum, 1 crore an annum, like way bigger than that. I noticed that they're all polymaths. Actually, they're all really curious people. That's why they're polymaths. They are curious even if there's no commercial goal there. Almost everyone in the forum was like that. I'll give you an example. Sir Demis Hassabis, the founder of DeepMind, started as a competitive chess player. Then he did game design. He actually made a theme park game. Then he was executive designer of the game Evil Genius, then stopped that, went and studied neuroscience, wrote a paper on episodic memory and memory recall in scenes, then started DeepMind, and then made an AI to play Atari games, then went and solved protein folding in medicine and life sciences. It's insane. It's like domains don't matter to these people, and it's so inspirational. In fact, just being there changed me in some way. It kind of reminded me that life is short, and we're all just here temporarily, and you might as well do everything you're curious or interested in. Because not only is that when you'll be most excited, but weirdly, it's where you will also make money and attract other people to work with you. Because that passion is genuine and true and driven by your curiosity. When I was 25, I would say things like passion is useless. You need discipline, etc., etc. I was wrong. It's passion all the way through, even if that passion doesn't make sense to other people. One more thing I noticed is that DeepMind puts in a lot of effort to explain things to people with basic science literacy. Like, they could have explained everything in a very complex way, but they made entire demos to try and explain their project, for example, on the human connectome or on AlphaFold. They are very, very simple demos you can use, so they're trying their best to communicate it to the masses. It's the opposite of what some people on tech Twitter do, for example, where they try to make things as cryptic as possible and do gatekeeping by not making things simple. They enjoy the complexity because it gives them status, but the folks at DeepMind are very, very different. They actually want the science to reach the masses, so they try to keep things simple. Okay, anyway, here's the good part. The next day, we got to DeepMind, the main office. Firstly, to get into DeepMind, you have to sign a non-disclosure agreement. So I can only reveal a small fraction of what I actually saw there and what I learned, but I'll try my best. Sometimes senior employees at Google India will joke with me saying, Varun, you've seen more of Google than they have, but DeepMind is really secretive. And that street, that specific street where DeepMind is, has a bunch of other tech companies. There's Meta right there too. So anyway, we first entered, got our badges. There's this amazing art installation in DeepMind's entrance. It's like looking through an infinite space. Very cool. And all the rooms have names of famous scientists. So we started on the 8th floor where we saw that general work setup. We weren't allowed to record some of it, but in general, it's a bunch of very, very smart people working on variety of different things, from life sciences to robotics. In short, I'll tell you 4 projects that I really liked and I was interested in. The first one is AlphaProof, which is solving international math Olympiads. Pushmeet told me, and you'll see this a little later in the video, that it does reasoning like OpenAI's O1. Okay, there's a chain of thought going on, but it uses a formal language called Lean to reason, so less hallucination. It's almost like it allows it to think in code. The next one, as you know, is AlphaFold. AlphaFold solves protein folding. For decades, scientists have been trying to figure out how proteins fold. Why? Because understanding this folding helps us do amazing things, like designing better medicines or diagnosing mutations. It looks at the basic pieces of a protein, called amino acids, and predicts how the whole thing will twist and turn into its final shape. They're now solving problems in weeks that used to take years or couldn't even be solved at all for PhD students. The next thing that DeepMind is working on is Project Astra, which is an always-on AI assistant that you carry with you in your glasses. It can help you see the world and it can help you with everything. You see a tap in front of you, you don't know how to fix it, you can say, well, AI, help me fix this tap. And the last thing that I was really excited about is, of course, VO, the video model. I mean, we work in AI plus content. Remember our product AlphaCTR that we built, or the AI avatars that we use that literally power the 100 million short form views? Any and all advances in models for content have an early user in me. So one big advantage for me to be there is, well, I'm able to use early access versions of these models before everybody else, and therefore we're able to run these experiments faster than others. Okay, 2 cool things about the DeepMind office. First, they have an amazing cafeteria with all sorts of food and drink, but to be honest, I don't care so much about food and drinks. Secondly, they have an amazing library. Like, the library signifies how much they care about being polymaths. And it has a lot of different books, from neuroscience to travel to physically based rendering in game development, and all the way to Java and HTML. I'm actually going to make a full video on all the top books in the library. And one of my goals in life is to have all those same books across all those topics in my house and actually read all of them. I was actually surprised to see that I've read some of the books. But one of my new goals in life is to make sure I have a perfect replica of that library in my house at some point. Not only that, there are copies of the Nature magazine all over the office. The library is very inspiring and I think it deserves an entire video on it. If you subscribe, I'll make a full video talking about every single book, or at least the top books there, so make sure you do that. And it also shows you what the ambitions of the people in DeepMind are. It's not really money. Money is a side effect, right? They've made a lot more money than everybody else because I think it's a side effect of just following their curiosities and being really good at it. Most of them are already very rich. For them, it's actually their ability to satisfy their curiosities and pursue this never-ending goal of learning more about the universe and our place in it. But I didn't stop there. You know, I'm a person from the outside looking in, and I wanted to talk to the vice president of research and ask him for everything. How does DeepMind work? How do they hire people? What kind of projects are they working on? And whether LLMs have hit a wall? And finally, what the path to artificial general intelligence is. An AGI system is supposed to solve all of these problem statements. It's basically supposed to encompass the entire library. And instead of me breaking down the conversation for you, I'm actually just going to place in the entire full conversation. Trust me, it's worth a watch and it'll give you a lot of ideas around what the future is going to be like. Ladies and gentlemen, this is Pushmeet Kohli, the VP of Research of DeepMind. Again, a polymath, and his work spans everything from using a camera to do motion capture all the way to medicine. Here goes. Pushmeet, thank you so much for doing this. I had a tour of DeepMind today, like the office. I don't think anyone, like most people sitting in India, know what's going on in DeepMind and how influential you folks are in AI. So what happens in these like mysterious halls?
It's like any sort of institution, any organization. We call it the intelligence factory. what we do is we extract intuition from raw material, which is in our case data. And this data can be data that has been carefully collected by scientists through experiments, or it could be data that we have created through simulations. But essentially, there is this amazing amount of data that we are collecting about ourselves, about the planet that we are living in, and how do we make sense of it all? It comes to a point where the data is so large that one single human mind is not able to make sense of everything that we have collected. And so that is where we need techniques like machine learning and AI, which are able to extract these hidden patterns within the data and allow us to make predictions that of quantities that are incredibly important.
I actually want to ask you a question on AlphaCode, because you've also worked on AlphaCode. I think the team has worked on AlphaCode. Competitive programming for a long time has been this marker of intelligence, for the human. It's like, well, here's my lead code score. But I think it's getting very good. Right? The AI there is getting very good across, all of these different platforms. And a lot of software engineers are worried, right? As in, hey, if this is going to be better than me at competitive coding, at what point does it build software by itself? Do you have thoughts on this, where this evolves over the next 4-5 years?
So what is the act of programming?
Problem solving?
I think one way to think about programming is basically problem solving. But in terms of the task description, what is the task? The task of programming is basically taking a specification of a problem. And that specification sometimes is an informal specification. Sometimes somebody says, oh, I want you to write a program that does this. That's an informal specification, right, of the problem. Or somebody might give you certain examples. They might say, well, here are certain examples. For this input, the program should give this output.
User stories.
Yeah, exactly, right?
Yeah.
So, but these are incomplete and informal specifications of what you were supposed to do. Right? And the act of programming is to take this informal, incomplete specification and translate it into something that is
very formal rules,
which is fully defined from the domain to which is completely crisp.
Yeah.
Right? And so the magic of a programmer is not in just doing that translation, but also in filling the gaps.
So in unzipping the problem statement into its constituents.
Also, but because many times the problem itself is unspecified. For most human problems, right? If I say, write a program to sort numbers, there are so many different things that are implicit. That when you write that program, it should take bounded memory.
Correct.
It should not run for infinite amount of time.
Correct.
It should run on a particular type of computer architecture.
Correct.
And I did not specify that, yet you got it. Right? You understood what I meant. Right? So part of it's what AlphaCode does is takes the specification and translates it, especially the problems that you see in competition programming, and does a great job in searching over this huge space of possible programs and tries to find the one which is consistent with the specification that is given at the in the contest, right? But if you think about the whole act of programming, that is a more general task, right? Where you have to somehow also think about what are the unsaid things in the program, that the part of the specification that was not explicitly laid out.
But AI today is also very good at filling in that context, right? I mean, it may not fill the context as well as a programmer who understands the problem space. Let's say I'm writing something for food delivery. Let's say I'm writing a food delivery app. I know the local environment. I'd say, well, if a driver stops for 5 minutes, then that's probably going to be a problem. And the AI might not know enough of that to fill that in, but I think it can fill in generic stuff, because today if I go to Gemini and say, give me a product spec for ABC, it will do a pretty good job, and the output is pretty long context.
But I would say that the act of prompting then becomes the act of programming in that case, right? Where now you are sort of programming in a higher level language.
Which is English.
Right? And the fact that it is an informal language, you do not completely formalize and specify the exact semantics of what is it, and yet the model is able to sort of work it out, is something that you have to sort of learn to to use.
So you're saying the only thing that will go away is you don't need too much knowledge of the syntax anymore. You don't need to be the best, translator, but you need to be able to formulate the problem well. So this word, the prompt engineer sort of word, then it becomes a real career then.
Yeah, it's like a prompt programmer. Like the prompt engineer is like prompt programming, right? But in some sense, like we don't see it that way because we think programming is something very precise.
Yeah.
And prompting is something that is not precise.
Yeah.
Like but in some sense, like at the end of the day, what you want is something precise.
Yeah.
Right? And now, regardless of whether you sort of use English to do it or whether you use a formal language like C++ to do it, the end goal is the same, right? You want something which is precise, which actually works for you.
I think this is the most nuanced answer I've got for this. So thank you so much for that. I asked this question to Demis on the roundtables, right? On the media roundtables. And you've worked on many different types of problems. The problem space of what DeepMind works on is wide. And, there's a bunch of stuff that you've done in game worlds, right? Game simulators, stuff like that. And there's also a lot of progress in robotics. And there's been this crazy, amount of chatter about general world models, which is sort of like multimodal models, but on steroids, right? And which is, take in everything. Don't just take in language, break it down into tokens, and then try to predict the next word, but take in everything. Take in sensory data if necessary. Take in everything. Do you feel like that might be, Demis said on the roundtables that, that we probably need an off-ramp to LLMs to AGI, right? Do you feel like that's the route to AGI? Like, what is your opinion on where that goes?
We exhibit different types of, Demis has an advantage in being able to answer this question because of his background as a neuroscientist.
Yeah.
I'm a simple computer scientist, so I'll sort of give a simple answer. I think my understanding of how we do things, there are different types of processes at play when we are trying to solve intelligence tasks, right? We need sort of episodic memory, but we also need working memory, right? And LLMs have been able to show that they are able to have amazing episodic memory, right? They can learn from a lot of data, and then they can sort of generalize in sort of remarkable and very surprising ways. But now there is an element of, do they have a structured working memory? Can they accomplish long-term reasoning?
Yeah.
Right, both the slow and fast sort of thinking view. And that is where some of the issues will be. Is there enough structure that is implicitly learned by these models that they can accomplish these kinds of tasks and can reason for a long time without making mistakes? So our belief is that there will be new advances that will be needed. LLMs will go a long way, but there will be sort of more advances needed to really accomplish everything that a human mind is today able to do.
Any potential candidates? Anything you've seen that's excited you? Any new paths?
So I think, just to give an example, think of our model AlphaProof.
Yeah.
So AlphaProof is a system that we announced this year, and which took on the maths problems from the International Maths Olympiad. And I don't know if you have seen these problems. I have seen them, and they have completely bowled me over. Like, they are incredibly hard problems, right? And they are challenging sort of problems, and even some of the harder ones, even field medalists would sort of find it difficult. I mean, they are not easy problems. They will take some time to sort of solve them. And what AlphaProof does, it tries to find the proof of these problems by doing search in the very large space of proofs, in a way that in a similar way to how AlphaGo did it, right?
Yeah.
It sort of makes guesses about what could be possible proofs and then tries to explore them. And AlphaProof sort of takes this even one step further. So given a hard problem, what it does, it basically tries to solve variants of that problem. This, in a way, mathematicians even sort of work on it. If you are sort of asked to prove a statement about general numbers, you will first try to sort of see what happens in the case of just one number, or for a restricted domain of even numbers, or just integers, before you try to sort of prove it for everything, right? So it tries to solve these variants, and in the process, it learns something about the problem that allows it to sort of really uncover some remarkable sort of proofs for these types of problems.
So you think something like an AlphaProof is a nice new candidate for path to intelligence?
Yeah, so I think it definitely has many advantages in terms of its ability to reason.
Got it.
Right? Because it leverages sort of a model, a large language model, to sort of reason about what should be the right step, but then also it has its formal elements, the symbolic part, which allows it to ground itself and explore things in a much more careful and acted manner.
It has a piece of the chain of thought reasoning that we see with some other newer models today, right? But here's the thing, sometimes I open chain of thought, I open the reasoning list, right? Because it's usually hidden on the other models, and it's nonsense, right? Sometimes it's like a breeze blew.
Yeah.
Then, there was a plate on the table. So it eventually gets to the right answer, but you're like, wait, what is it doing to get here?
Yeah.
So, but very exciting that you think that's a good path as well.
Yeah, so I think in the case of AlphaProof, we are working with formal language. So the final sort of proofs that you get, we know, we can check them.
Got it.
Whether they are correct or not. So unlike basically sort of a chain of thought with informal language.
Got it.
In the case of AlphaProof, you're using a formal language, which is the lean programming language, so you know whether it's right or wrong.
So it's doing chain of thought reasoning in code.
Yeah.
That is insane. That's a very smart idea.
Yeah.
Hey, I want to talk about something else, right? Yeah. And this is one of those parts of DeepMind which, or at least one of the things you've produced, which I think it's a genius solution, right? Which is SynthID. Let me see if I understood it correctly, which is, let's say somebody is generating text.
Yeah.
You found out a way to watermark that text, right? By saying, look, if you have a sentence and you have 5 words and then the 6th word is going to be generated, there is a probability of the words that are going to be generated. Let's say the 5th word to be generated is dog. Not dog. Let's say if the 5th word to be generated is delve, right? Just to give a better example. Yeah. Instead of delve, let's shift the output a little bit. Let's use the word dig instead, right? And you do this, in a bunch of places across the written text. And therefore, now you have a signature of slightly shifted probabilities of words. And that's how you're watermarking it. Yeah. Is my understanding of this correct?
Yeah. So I think SynthID is a watermarking solution. What it allows you to do is tag AI-generated content and then identify it. And that's very important, because if you see the whole ecosystem of information, some of it will be generated by AI. You want to understand what was AI generated and what is not, right? And so SynthID leverages a number of different mechanisms to watermark different modalities. So for text, it uses this sampling mechanism, the one that you were sort of describing, and that sampling mechanism essentially exploits the entropy in the LLM, because there is very little space. So for the case of sort of images and video and audio, these are high dimensional signals.
So you can throw a pixel somewhere.
So you can sort of somehow inject certain sort of biases which are imperceptible to you and me.
Got it.
Right? But yet would be persistent, in the sense that if you take that signal, you transform it some way, we will still be able to detect that actually this was the AI generated signal, even though you changed it. Because we are able to sort of extract that signature even after transformations.
Yeah.
Because there's a lot of room.
But with SynthID, I'm just thinking like a malicious actor.
Yeah.
Let's say I generate something with SynthID.
Yeah.
Then I stop using AI and I use something like a paraphrasing bot. Yeah. And there are a bunch of paraphrasing bots that don't use AI, that sort of rejumble the words. Yeah. Would it still work despite that?
So in the case of text, not. Yeah. Because it has changed the word distribution. So the text case is particularly hard.
Yeah.
In the case of images and video and audio, we are much more robust. But in text, you have a relatively low dimensional signal, and there is little room to actually inject a signature there, right? And so
because too much and people would know.
Exactly. You will change the meaning or you will change it in a very sort of prominent way. And therefore, SynthID for text essentially exploits the entropy of the distribution that the LLM has. So if you say the capital of France is, now the entropy is 0 because there's only one answer, Paris.
Correct.
So in fact, for this particular statement, SynthID can't do anything. Right? It will be just one answer.
Correct.
So we can't. But if you said, my favorite fruit is, now it could be a mango, it could be a papaya, it could be a sort of...
and it's much easier with words like delve, right?
Yeah, it's in the context, right? Delve is basically, it's much easier because you can replace it with many other words, right? And many other words are interchangeable. So that's the entropy that we exploit to then incorporate a signature.
Yeah, very fascinating. You know, I don't know if you've seen this, right? And I assume you haven't seen it, so I'm going to show you once. So I make content on Instagram that is short form content, that is purely synthetic. Right? I'm just going to show you an example. For example, this one, right?
Yeah.
This is a purely synthetic.
India's internet and someone just fixed Apple's awkward power button problem.
Right? So the video, I mean, the lips are restitched, right? Like it uses, an avatar system for it. The audio is completely synthetic. It sounds like me. It has intonation. It sounds good. And, one question I have with SynthID, would it be applicable to this? Because my biggest worry is, look, there are going to be a bunch of platforms where, just upload a bunch of data by somebody or like, an uninterrupted 3-minute clip. And now the audio samples that, some of these models require to just, give you a nice output is like 3 seconds, 10 seconds. So it's not very hard to make clones. And if you see Twitter, there'll be a bunch of, people talking that sound like celebrities, look like celebrities. Is there a mechanism for SynthID there?
Yeah, absolutely, right? So you can sort of, so in SynthID, we have one particular use case of SynthID is 0-bit watermarking. So in 0-bit watermarking, we are essentially saying, is this AI generated versus not? But there is another version of watermarking where you say, I want to actually embed information in the signal. Where the person who is sort of consuming that signal then can understand, oh, this was the origin. This is the person who actually sort of developed it, and this is the model that actually made it, and so on, right? So give much more information to the consumer to be able to make an informed choice of what they are seeing.
That's very cool. So I would say now when you click on images in Google, maybe in the future, we'd know very quickly what's AI generated and what's not, because slowly the internet is moving to much more AI generated. Like if you click on images in Google now, there's just so much AI generated images, right? So it's crowding out the internet. Very cool. I think, I've learned a lot. I can ask you 500 other questions. It's super, super exciting having you here. I have one last question, right? I went to the DeepMind library today. It was awesome. What's your favorite book in the library?
So, I mean, there are many. But
across all disciplines, it's like the Polymath's candy store.
Yeah, it's an amazing place, right? I mean, there's so many, but Charles Darwin is a personal sort of hero of mine. So the Origin of Species would be my favorite.
Thank you so much, Pushmeet. Thank you so much for doing this. And yes, I hope I get to see a little more of DeepMind before I leave. But yeah, thank you.
Yeah, pleasure.